Good morning, grade 5. Today, inshallah, we will be having a new lesson, classifying triangles, page R65 in your math workbook. So, what are triangles? What is a triangle? A triangle is a two-dimensional, flat, three-sided shape. What do I mean by two-dimensional flat? I mean, it's not a solid figure. It's not a three-dimensional figure. It's a plane figure. The word two-dimensional means it's flat, plane. Okay, you can see it from one or two sides. Okay, now three-sided means it has 1, 2, 3, 1, 2, 3, 1, 2, 3 sides. Those are some examples of triangles. They look different. They are not the same triangle. They have different sides, different angle measures. They look different, but they are all triangles. So a triangle is a two-dimensional, flat, three-sided shape. How to classify triangles? If we have a lot of shapes, if we have different shapes for triangles, how can we classify them? We need to know a criteria to stick to in order to classify the triangles, to differentiate between their types. I want to differentiate between their different types. So the first way to classify the triangles or to differentiate between the different types of triangles is by angles. We will explain furtherly how we will differentiate by angles. What do we mean by this exactly? And the second way is to differentiate by side length. So there's two ways. The first way is to differentiate by angles. The second way is to differentiate by side length. The side length. Do you remember the angles, measuring angles, the past lesson? Remember it? So an angle, remember how did we differentiate the angles? We said we have acute angle, obtuse angle, acute, obtuse, and straight angle and right angle, right? We had acute, obtuse, straight, and right angle. So we had four types of angles. Four types of angles in general in differentiating the angles. But now we are today talking about the triangles, not the angles. We are talking about the triangles. We need to classify the triangle according to its angle. So here in this triangle, we have an angle here and another angle and another angle. We have three angles and three sides. Again, here with a different color, we have an angle, another angle, and a third angle. So we have three angles and three sides. Same here, one angle, two angle, the third angle. So we have three angles and three sides. So sometimes I will need to differentiate according to the angle, and in other times I'll need to differentiate by the sides, and in other cases I'll need to differentiate using both criteria. Let's see. So by classifying angles, I will only need in this triangle classification the right, obtuse, and acute. There is no straight. Right, obtuse, and acute triangles. So from what we have studied together, if I asked you to guess, the right angle should have exactly 190-degree angle because of the word right. Remember the word right angle, how is it? Right angle is a 90-degree angle. So a triangle, in order to call it a right triangle, must have 190-degree angle. Again, a right triangle must have 190-degree angle. I don't care about the rest. The rest will be any other number. Maybe they be 20, maybe they 30, 40, whatever. I care about if I see only one angle having 90 degree, I will name it as right triangle. What about the obtuse triangle? From what we have studied together in the angles, what do you think? Of course, it must has one obtuse angle. What do I mean by one obtuse angle? From what? Bigger than 90, right? But less than 80. Must be greater than 90 but less than 180. Greater than 90 but less than 180. And what about the acute triangle? The acute triangle has 3 acute angles. It's different from the other two triangles, different from the right triangle and the obtuse triangle. No, the acute triangle must have 3 acute angles, not only one acute angle, not 2 acute angles, but 3 acute angles in order to call it as an acute triangle. Now let's look at some examples of these triangles. In order to implement what we have took in words, we have to see it in pictures in order to understand fully. Okay, let's now see the first example here. When we said the right triangle, okay, we will take the first one, the right triangle. The right triangle must have, we said that it must have what? Must have only one 90-degree angle. So a right triangle must have one angle that measures 90 degree exactly. Like what here? Look at this part. Isn't this 90 degree? Yes, this is 90 degree angle. And here as well, it's the same but inverted, right? So this is a 90 degree. If it has only this triangle, if it has only one 90 degree angle, we will name it as right triangle. Right triangle. I don't care about this the other 2 angles, how much they measure now. I only care if I see one angle here having 90 degree, so I will directly call it as right triangle. Right triangle. Right triangle has only one angle measuring 90 degree, and that's why we named it right triangle. We named it right because it has not one angle that has 90 degree. Okay, how can I know that it has 90 degree? I will place the corner of the protractor here, the middle part of the protractor, and I will measure with the protractor normally, like how we used to measure the angle before in the past lesson. Okay, and then I will make sure it's actually 90. I will put here, it will be the protractor will be the center of the protractor here, and you can find it measures exactly 90 on the protractor, to this side, to the 0 side, and here to the 90 side, and you will find it's actually a 90 degree angle. And then after you know it's 90 degree angle, we will name it as a right triangle. Now let's go for the obtuse triangle. We said here that the obtuse, now we're done from the right triangle. The obtuse triangle has one obtuse angle, and we said that the obtuse angle must be greater than 90, right? But less than what? Less than 180, right? Okay, so for example here, this is an obtuse angle. For example, it's 120, right? So 120 angle, I don't care about this side, I don't care about this side, I don't care about those 2 angles now. I'm just caring about this angle here. If I see that it has one obtuse, this one is the one important. If I found out that it has one obtuse angle, so I will directly call this triangle as an obtuse triangle. Obtuse triangle. Here it's the same, this is an obtuse angle, and here as well obtuse angle. So if I have one obtuse angle in a triangle, I will directly call it obtuse triangle. What about the acute We said that the acute here, now we're done from the obtuse triangle. We can measure it as well with the protractor normally. Now let's see the acute triangle. Must have 3 acute angles. Miss, if it has 2 only, no, we cannot call it acute triangle. If it has 1 acute angle, no, we cannot call it acute triangle. Must have 3 acute angles. So let's see. An acute triangle must have 3 acute angles. Each one must measure less than 90. For example, here this is 60. So it's acute, right? And here 60 if you measure it with the protractor, and here 60. So 60 and 60 and 60, they are all 3 acute angles, and they are less than 90. Less than 90. 60, 60, 60, and they are all less than 90. So I can name this triangle as acute triangle. Acute triangle. Again, another example here. This one as well could be 60, 60, and 60. If we measure it, we can find it. They are all having the same, not the same, but they are all acute angles. They are all acute angles. So we name this triangle as acute triangle. Acute triangle. They must be less than 90. So this is the first thing here. We have classified them all according to the angles. We finished the acute triangle, right? We finished the acute triangle. There's important note here that the angles in any triangle in the world, they all must be equal. They all must be equal to 180. Their sum. Like for example, here 60 plus 60 plus 60 equals 180, right? 60 plus 60 plus 60 equals 180. For example, here we are having 120, right? So there must be here 30 and other one here 30. In order to add them together, 120 plus 30 equals 180. So they must all be 180. All angles together must be 100, equal to 180 when we are classifying by angles. So again, let's say that if we want to classify, there's 2 ways for classification. One by angles, and we said that all the triangles must have 180 degree. The sum of all angles in any triangle is 180 degree. The second way is by the side length. So if I want to classify again by the first way, by angles, we have 3 types of angles. 3 types. The first one is acute, and the second one is obtuse. The third one is the right triangle. Right triangle, obtuse triangle, and acute triangle. Now if I'm going to classify the triangle by its side length, we are going to have, classifying by side lengths, we're going to have 3 types of triangles. The first one is the equilateral triangle. The word equi means equal. The word equi means equal. So equilateral triangle has 3 equal side lengths. 3 equal side lengths. We will explain furtherly now. And the second type of the triangle, we name it as isosceles triangle. Isosceles triangle has 2 only equal side lengths. 2 equal side lengths. And the third triangle, we name it as scalene triangle. It has no equal side lengths. No equal side lengths. Again, we have three types of triangles according to the classification of side lengths: equilateral triangle, isosceles triangle, scalene triangle. Let's look on some examples now to see. So here the first one is the equilateral triangle. Equi means equal. So they will be all of the three sides will be of equal lengths. So here we have 3 feet. This side equal 3 feet, and this side equal 3 feet, and the third side equal 3 feet. So they are all of the same side length. We name this triangle by equilateral triangle. The second type of triangle is the isosceles triangle. Isosceles has two equal side lengths only, and the third is not equal to them. So here we have this yellow side is 10 inches, and the second side of the triangle is 10 inches as well. So they are both equal, because if we get here one line in the middle, if we draw one line in the middle, you will find that this side is equal to the other side. Again, isosceles triangle is the triangle that has two equal side lengths. So if I look on the triangle, it has 10 inches, 10 inches, and 20 inches. The third side is not equal to the two other sides. So if I have two sides equal in any triangle, I name it as isosceles triangle. The third triangle, we said that three side lengths are not equal. They are all of different sizes. Let's look here: 10 inches, 15 inch, and 20 inch. So none of them is equal to the other, right? They are all different sizes. They are not the same. So if I find this triangle looking like this, having three different sides lengths, I name it as scalene triangle. Scalene triangle. Again, if I want to classify by side lengths, I have three types of triangles: equilateral triangle, isosceles triangle, scalene triangle. Equilateral, from the word equal, the three sides must have equal lengths, and isosceles has two only equal side lengths. The scalene triangle has no equal side lengths. They are all different from each other. Now let's see here. We have this triangle. It asks you, what kind of triangle is this? We have 90 degree here, right? In this triangle we have a 90-degree angle, which is a right angle, and we have agreed together that the triangle that has right angle inside it, we name it as right triangle. So, and it tells you that all sides are different lengths. All sides are different. Which type of triangle we had that has no sides having the same length? It's of course the last one, which was scalene triangle. So I can now name this triangle as right scalene triangle. Right scalene triangle. Right scalene. Why right scalene? Because right, it has a 90-degree angle. It has a 90-degree angle. So we name it as right angle, right triangle, and three different sides. So I name it as scalene triangle. Together, if I want to name this triangle, I will say right scalene triangle. Right scalene triangle. It's made up of the two classifications together, classifying according to the measure of the angle, which is the right, and classifying according to the measure of, or to the side length. So here is the side length classification, and here is the angle measurement classification. Okay, what kind of triangle is this? I have one obtuse angle here, which is 120, and I have two equal sides only, and the third is not equal. So according to the angle measurement, right, we have obtuse angle. So what's the name of the triangle that has one obtuse angle? It is the obtuse triangle. Obtuse triangle. And what is the name of the triangle that has two equal sides only? Go back here in the page and we will find that the triangle that has two equal sides, we named it as isosceles triangle. Isosceles triangle. So this is a obtuse isosceles triangle. Yes, it's obtuse isosceles triangle. Why obtuse? Because it has here an obtuse angle, which is 120, and has two sides, two equal sides, so I named it as isosceles triangle. Again, remember, important, that the sum of the measures of all the angles inside the triangle, they are all equal to 180 forever and ever. All of them must be equal to 180. For example, here, as I showed you before, 60 plus 60 plus 60 equals 180. They all must be equal to 180. So now this is page R65. Let's try to answer the questions together. The first question asks you to classify each triangle by its sides and then by its angle. So let's look for the sides first. We have here 8 centimeter, one side having 8 centimeter, the second side is 8 centimeter, and the third side is 14 centimeters. So we have two only equal sides. Two equal sides. Let's look here. What's the two sides that have the same length? What's the name of this triangle? It is isosceles triangle. It has two sides of the same length. Two sides of the same length. So it's an isosceles triangle. Okay, now we have finished the sides. Let's go for the angle. I have here 128 angle and other two angles that are 26 and 26. Two acute angles and one obtuse angle. I said one obtuse angle. So if I find any triangle that has one obtuse angle, we can name this triangle as obtuse triangle. Obtuse triangle. So 128 is an obtuse angle, so I named the triangle as obtuse triangle. I have here isosceles because it has two equal sides, obtuse because it has one obtuse angle, triangle. Let's now go for the second example. I have here 3 feet. This side, the second side is 3 feet, the third side is 3 feet. Oh, they are all equal. The sides are all equal. What did we name this triangle that has all equal sides? All sides are the same length. We named it as equilateral. Equilateral. So now I have known it's an equilateral triangle. Okay, let's now look for the angles. The angles are 60, 60, 60. Oh, it has 3 acute angles. What did we call this triangle that has 3 acute angles? Acute triangle. Acute triangle. Here's it. All angles are less than 90. Acute, like this one. Acute triangle. So we named it equilateral acute triangle. Why equilateral? Because it has 3 sides of the same length. And why acute? Because it has 3 angles that measure less than 90, which are acute angles. Now let's go for the third example here. 5 inch, 3 inch, the second side is 3 inch, and the third side is 4 inch. They are all different. 3, 4, 5. They are all different. What's the name of that triangle that has 3 sides having different lengths? What's the name of it? Here's it. No sides are the same. We called it scalene. Scalene triangle. So this is a scalene triangle. Okay, now let's go for the angles. We have one right angle here that measures 90. If it's a right angle, so what's the name of the triangle that has one right angle? We call it right triangle. So again, we have here scalene right triangle. Why scalene? Because the three sides are of different measures, and why I call it right triangle, I have one right angle which measures 90 degree here, so I called it scalene right triangle. I hope I made it clear, inshallah, and that you understood it nicely. Now let's go for the second question. It asks you to measure the measure of two angles of a triangle are given. Now I have the measures of two angles inside the triangles, and he wants you to get the measure of the third angle. Like for example, here is a triangle that has 100. This is 100, and this is 40. So it asks you to get the third. This is unknown, we don't know it. To get this one, to get the third angle measurement, how would it measure? How much? What is the number for this angle? How can I know? Remember when I told you that the sum of all the measures of angles of a triangle must be 180? That the all must be equal to 180? Like if I added 100 plus 40 plus this unknown, it must be equal to 180. Okay, so I mean 100 plus 40 plus what? Equal 180. Okay, let's now count. Add 100 plus 40 equals 140. 140 plus what? Equals 180. I can now say 180 minus 140 equals the unknown that I want to know. Equals what? Equals 40. So the third angle is equal to 40. How did I know? From adding both 100 plus 40 equals 140, and then because I know that the all must be 180, the measures, all of them must be 180, so I minus the 140, what I have from what I know. 180 minus 140 equals 40. Okay, did you get it? Now let's go for the second one. We will always do the same. 180 minus what we have, we will add them together. Okay, and then we will say 180 minus what we have, 180 minus what we have. So I will always add those two together, and then I will say 180 minus the two angles measures that I have. Let's now see here. I have already wrote the answers. 180 minus 40 plus 100 equal 40, and here 180 minus 14 plus 98 equal 68, and the last one, 180 minus 38 plus 38 equals 104. So the third angle here is 104, the third angle in question number 5 is 68, and the third angle in question number 4 is 40. I hope I made it clear, inshallah, and see you in the next lessons. Please answer page P65, the next page, as homework. Try to answer whatever you know inside it, and send me the homework on ShareEdu or WhatsApp. Thank you very much.